All right, guys, we're going to start chapter 4. Chapter 4 is all about sampling and surveys and experiments and observational studies. So today our focus is going to be about understanding the difference between a population and a sample, as well as looking at different types of sampling techniques and a simple random sample. So here we go. First thing, what is the difference between a population and a sample? So we want to think of a population as the entire group of individuals we want info about. Your sample is the subset or the group of the population that you actually gather data from. So it's very difficult, especially when you're dealing with large populations, to actually gather data from the entire population. So instead, we take a subset of that population, which is your sample. We gather data on that sample, and then we use that information to try to make some inference about the entire population. A census, which is probably a term that you've heard a lot about recently since the US is going through their census, is when you collect data from every individual in the population. Now, like I said, this is obviously very difficult to do because it's difficult to reach everybody, find everyone, and sometimes it's not even feasible to do it. So for example, say you wanted to collect data on the length of a fish in Shadow Lake. It'd be impossible to get a census without actually draining the entire lake out. So instead, you can get a sample, hopefully a representative sample of fish in the lake, and use that sample data to make an inference about what is the average length of a fish in the lake or something like that. So the whole idea here is you have your general population here. You take a sample, which is that subset of the population. You want to make sure that that sample is representative of the population, and you use that information to make an inference about the population. That's what statistics is all about. Two examples that we'll go through in class about identifying the population in the sample. If you want to take a look at those ahead of time, feel free. So choosing a representative sample from a large varied population is not that easy. Again, this is something that you see a lot about when we're going into an election, okay? How are they obtaining that sample for the poll that they're gathering on? Finding a representative sample of the electorate is not something that's easy, especially when you're trying to model something for an entire state or the country or something like that. So the 3 steps in planning a sample survey. First thing that you want to do is you want to identify and define the population you're trying to describe. So who are we trying to gather data on? Okay, are we trying to gather data on the entire population of the US, on all South students, on residents in Middletown, on animals in the forest, whatever we're trying to capture data on. Step 2, say exactly what you're trying to measure. Do you want to measure the average length of a fish? Do you want to measure the proportion of people who are going to vote for a candidate? Whatever you're trying to do that. And step 3, decide how to choose a sample from the population. So how are you going to obtain that sample? How are we getting the 1,000 likely voters or the fish or whatever we're trying to do? And remember, you want that sample to be representative. It should be modeling the population. It should be like a mini version of the population. So what will poor sampling methods create in our results? Bias. Okay, you hear all about this all the time in the news. The poll is biased. Okay, biased results. All right, we don't want biased results. So if we're creating a representative sample, then we won't have biased results. So what is bias? A study shows bias if it is very likely to underestimate or overestimate the value we want to know. So say I'm creating a poll, right? And the sampling technique that I use, I'm only going to, I want to know, I want to ask a question of, do you favor a certain candidate? Okay? And I only go to an area where I know that there's many people who favor that candidate, or I only ask the people who are attending a political rally for that candidate. Obviously, that's a biased sample, and it's going to overestimate the actual percentage of people who do this. Another example is, say I want to estimate the percentage of South students who are going to a four-year college, but I only ask the people in my AP Stat classes. Obviously, that's a biased sample that's going to overestimate the actual percentage who are going to a four-year college, because the AP Stat students are more likely than the general population to attend a four-year college. So one such technique that could lead to bias is a sampling bias, which is called a convenience sample. So a convenience sample is like the lazy way, all right? We only select individuals who are easy to reach. This is lazy sampling, okay? I only ask my friends, or I only ask the first 100 people that I see. Okay, that creates bias. You want to avoid convenience samples. You have to have some type of random sampling technique when you're doing this. Another type of random sample, another type of sampling technique that leads to bias is what we call a voluntary response sample. So in a voluntary response sample, it allows people to choose to be a part of the sample. Now, the issue with voluntary response samples, they show bias because people with strong opinions are the most likely to respond. So this is like the type of poll that you often see on websites. Say like after a debate, you'll see a poll on a website. You go to asburyparkpress.com or nj.com. They say, who do you think won the debate? And you're choosing to be a part of that sample. That is a voluntary response sample. And the only people that are choosing to answer that are the people that have the most strong opinions. Okay? So that is not representative of the entire population. Think about reading reviews for things online. If you just think something's okay, or something's, it's fine, it's not great, it's not terrible, you're not going to sit there and write a review. So those reviews that you read online for products or restaurants or things like that, those are samples that are examples of voluntary response samples. Those are people, a subset of the population of people that have gone to that restaurant or bought that product that feel most strongly and have decided to write that review. These types of samples are not accurate, okay? So you want to think here about like internet polls where people are choosing to be a part of that sample. It's self-selection. They are not accurate. These are bad sampling techniques. Two more examples that we'll look at in class. So in statistics, the conclusion of your study will be rendered invalid unless you've done everything in your power to ensure that the sample is collected truly, utterly, and completely random. And this is a crucial thing. How do we obtain that random sample? Okay? So in order to sample well, one of the most common sampling techniques that we use is what's called a simple random sample, or an SRS. An SRS is a completely randomized sample. So in order to do this, there are several ways in which we can choose a simple random sample. We can draw names out of a hat. We can use random numbers from the calculator. We can use technology such as random.org. We can use a random number generator. But it's crucial when you're selecting a sample that you select a random sample. So why choose a sample by chance? To be completely fair. You might think, oh, I'll just ask these people that I see. That's random. I'll just pick these random people. No, random means that you're using some type of chance process to make the selection. We want to ensure that every individual has the same chance of being selected. So random sampling uses a chance process to determine which members of a population are included in the sample. Now, these chance processes could be something as simple as, and you'll see the most easiest way to create a random sample is to just pick names out of a hat. Now, obviously, we have technology now that could help us in creating a random sample, but that's the easiest way to go about doing it. Specifically, a simple random sample, or abbreviated as SRS, so anytime you see SRS, that means a simple random sample, of size n is chosen in such way that every group of n individuals in the population has an equal chance of being selected. So for example, now with the COVID restrictions, they're doing a lottery to determine what students get the football tickets. So everybody's name goes into a hat or a generator or however they're doing it. They mix it all up, or they use some type of a random technique, and they randomly select 100 students to go to the football game. They are using a simple random sample technique. Okay, every single group has the same chance of being selected, and every person has the same chance of being selected. The easiest way to choose a simple random sample of n people is the hat method. So if you're ever asked a question and you have to use a simple random sample technique, use the hat technique. But you have to be specific in how you're explaining how to do that. So you want to label, you want to randomize, and you want to select. So what exactly does that mean? First of all, we have to put all individuals step 1, or the numbers for individuals, on identical slips of paper. After we do that, put the slips into a hat, mix well, and draw the slips of paper. I'm going to say N for the number that you need. Now, depending on whether, and generally speaking, we want without replacement, okay, you're going to keep the drawn names out. That would be without replacement. Until N unique slips are chosen. And those slips that are chosen, those corresponding people, would be a part of your sample. But it's very important that you are specific in your explanation of how to create that random sample. In addition, people use random integers generated by the calculator or some type of website to choose samples. So on the calculator, you can do that by going to Math, over to PRB, and then to randint. And the calculator can generate random integers for you. It'll ask for your upper bound. So if maybe you want from 1 to 100 or something like that. You can also use technology, random.org. But it's important that you're specific in how you're doing this. So when we're using technology, you want to start by labeling. Give each individual in the population a distinct numerical label from 1 to n. So I'm going to label each person in the population from 1 to 100, or 1 to 1,000, or 1 to 1,500. Then I'm going to randomize. I'm going to use a random number generator to obtain n, and this is the crucial thing, unique or distinct, meaning I cannot have repeats, integers from 1 to n. Those integers that I choose, the peoples corresponding to those, would be a part of my sample. The final technique that you could use to create a random sample is an old school technique that's called using a table of random digits, or a random digit table. So in using a random digit table, your first step, once again, is to label. In this technique, you're going to give each member of the population a numerical label with the same number of digits, and that's crucial. You only have to use that technique in using a standard normal table, or sorry, not standard normal table, a random digit table. So you want to use as few digits as possible. So for example, say I have 200 students that I need to label, okay? I have to label them with equal length. So I'd have to label them from 001 to 200. I can't label them from 1 to 200 when I'm using just this technique of a random digit table. Once again, you're going to randomize. When using a random digit table, which we're going to do during class, you're going to read consecutive groups of digits of the appropriate length from left to right. Ignore any groups of digits that are outside of your region, so from, in this case, over 200. And ignore duplicates as well, so no repeats. Okay, it's always important that you're including that when you're talking about how to obtain a random sample. So just to define what this table of random digits are, or a random digit table. So a random digit table is a long string of digits from 0 to 9 with these two properties. Each entry in the table is equally likely to be any of the digits from 0 to 9. The entries are independent of each other, meaning that there is that knowledge of one part of the table gives no information about any other part. And again, this is an old school technique on how to obtain a random sample that you're not going to see that often, but you might see a multiple choice question or something like that on the AP exam. We'll look at an example and we'll look at the full random digit table in class. I know there's a lot of writing in this chapter or in this section that you had to do. That's what this chapter is all about. There's a ton of writing in this chapter. There's very, very little math, but it's important that you understand all the different sampling techniques. Today, make sure that you know about convenience sampling, about voluntary response sampling, what it means to be biased, and most importantly, why we take a simple random sample, how to take it, and the importance of taking it. I'll see you guys in class.